Hello class, today we're going to talk about our special right triangles. And there's two kinds of special right triangles. What we have 45, 45, 90s, called named because of the angles, 45 degrees, 90 degrees, and 30, 60, 90s, again, named for the angles. And they do some special things, kind of shortcut the Pythagorean theorem. So here is the 45, 45, 90 triangle theorem. And what this says is that the hypotenuse is square root of 2 times as long as each leg. So with the 45, 45, 90, since the base angles are the same, that means these are going to be isosceles triangles, right? And so whatever x is, whatever the length of a leg is, the hypotenuse is going to be x times square root of 2. So here's some examples here. See, we have a leg of 1, and so the hypotenuse is 1 square root of 2. Leg length of 2, 2 square roots of 2, leg length of 3, 3 square roots of 2, 4, 4 square roots of 2, and so on. All right? So let's take a look at this. We need to find the value of x in these two right triangles. Okay? Put our answer in simplest form. We're not going to be using decimals. We're going to leave it as square root of 2 or whatever. So let's take a look at A. With A, we have this is a 45-degree angle. That's a right angle, so triangle sum theorem says this can only be 45 more degrees, right? So this is a 45, 45, 90 right triangle. A leg has a length of 8, and the hypotenuse is the leg times the square root of 2. And x is our hypotenuse, so that's 8 times the square root of 2, or 8 root 2. Right? So that's pretty simple when they give us the leg. It's not too bad. Slightly more complicated when they give us the hypotenuse and we need to find the leg. So in B, we see that, hey, this is an isosceles triangle. That means base angles are congruent. And since this is a 90-degree angle, because it's a right triangle, then these two must be 45, 45. So we've got a 45, 45, 90 triangle again. Again, the hypotenuse is equal to the leg times the square root of 2. But this time they gave us the hypotenuse. So we have 5 times the square root of 2 equals x times the square root of 2. Well, divide both sides by the square root of 2, and x equals 5. So not too bad, since this has the square root of 2, a little bit more cumbersome when you don't have the square root of 2 right there in the hypotenuse. And we will do one of those, but not yet. 30, 60, 90 right triangles. What we have here, the hypotenuse is twice the length of the short leg. So this is the one opposite the 30 degrees. The long leg is going to be the short leg times the square root of 3. All right, so here's some examples. See, if the short leg is 1, the hypotenuse is 1 times 2, which is 2. And the long leg is 1 times the square root of 2. Over here, the short leg is 3. Hypotenuse is 3 times 2, which is 6, and the long leg is 3 times the square root of 3. We have 4, 4 times 2 is 8, and then this is 4 times the square root of 3. So you see how this works no matter what size that triangle is. And let's take a look. Here we need to find the value of x and the value of y. So we need the length of the short leg, and we need the length of the hypotenuse. Well, it gives us our angles here. So this is a 30, 60, 90 right triangle. Let's find x first. That short leg is almost always going to be the easiest one to find. Right? So short leg is the longer leg equals the short leg times the square root of 3. So this is going to be a little bit different because we don't have any square root of 3s. So that makes it slightly more complicated. So the long leg is 9. The short leg is x times the square root of 3. Got to solve for x. So we divide that square root of 3, and if you remember, we don't like having square roots in the denominator. It's no good. No radicals in the denominator. So to get rid of that square root of 3 in the denominator, we multiply numerator and denominator both by the square root of 3. Right? Because the square root of 3 times the square root of 3 is just 3. So now I have 9 square roots of 3 divided by 3. Well, 9 and 3, those simplify, and this just becomes 3 square roots of 3. So x, our short leg here, is 3 times the square root of 3. Now to find y, the longer leg. Well, the longer leg is not the long leg, the hypotenuse. The hypotenuse is equal to the short leg times 2. So we have the square root of 3 square roots of 3 times 2, which is just 6 square roots of 3. So y is 6 square roots of 3. So not too bad. A little bit tricky on this part. If they give you something that normally has a square root in it, and you got to back it up to something else. Okay, so what I want you to do is work out these 4 problems. Pause the video, find the value of the variable, work this out, then come back and check your answers. Alright, you're back. Let's see how you did. There's all of the answers there. For those of you who got this right, great, good for you. You can fast forward a little bit. For those of you who didn't, here's number 1. Again, isosceles right triangle, so this is 45, 45, 90, gives us the hypotenuse. So what we have to do is divide by that square root of 2, and so we end up with 2 equals x. Number 2, again, isosceles, so it's a 45, 45, 90, and this time they give us the leg, so what we're going to do is multiply the leg times the square root of 2, square root of 2 times the square root of 2 is 2, so y equals 2. For number 3 there, this is a 30, 60, 90. So here we're looking for the long leg, which is the short leg times the square root of 3. So the short leg is square root of 3, so square root of 3 times the square root of 3 is 3. Now this one's a little bit different. Some of you might have thought, hey, these are all the same size, so this is isosceles, it's going to be that 45, 45, 90. But we're just looking for the height. And this is an equilateral triangle, which means these angles are 60-degree angles. So we have 60, 90, and so this is going to be 30. We're just looking at this one little half of the triangle here. So we're looking at this half is a 30, 60, 90, where the short leg is 2. So we have the short leg, 8. Short leg is x, which in this case is 2. 2 square roots of 3 is h. There it is, 2 square roots of 3. So not too bad. So here we have a road sign. Got a nice little yield sign. It's an equilateral triangle. We want the area. Okay. Well, area of a triangle. First we got to find the height, because 1/2 base times height, right? So we got to know what that height is. So we're going to break this down. We can draw this out. The height is going to make this right triangle, right angle right there. All right. And so we have 18 inches for the short leg of this little right triangle, okay, the 30, 60, 90. And so if 18 is the short leg, the long leg is the short leg times the square root of 3. So that means our height is 18 square roots of 3. And then we can take that and plug that into our area formula, 1/2 base times height. So we have 1/2 times the base, which is this entire 36 inches, not just the 18, because we're looking all the way across the equilateral triangle. So 36 times 18 square roots of 3, which is approximately 561.18. So our area is about 561 square inches. All right, that's because the square root of 3 is irrational, so we're going to have to round that. All right, so here's another one. Got a tipping platform, which is a ramp they use to unload trucks. We want to know how high the end of this ramp is if the tipping angle is 30 degrees, and how high would it be if it was 45 degrees. All right, so the tipping angle is this angle right here, where everything's going to dump out of the back of this truck. All right, so let's start with the 30 degrees, which makes this a 30, 60, 90 right triangle. So it's going to look like this. All right, looking for h right there. All right. Well, 30, 60, 90, we're looking for h. This is the short side. We have the long side. So our long side is 2 times the short side. Long side is 80, so we divide by 2. And so if it's a 30-degree angle, it would be 40 feet. All right. Now, what if it's 45, 45? With, I don't know what that is. All right. So 45-degree angle, we've got a 45, 45, 90. All right. Hypotenuse is 80 feet. Well, the hypotenuse is equal to the leg times the square root of 2. So we divide the square root of 2, and 80 divided by the square root of 2 is approximately 56.6. So if it's 30 degrees, we have a 40-foot high ramp. If it's 45 degrees, then the ramp's going to be approximately 56 feet 7 inches. All right? Because remember this 0.6, this is tenths of a foot, this is twelfths of a foot, inches. All right. So what I want you to do is work out number 5 and 6, pause the video, and then come back and see how you did. All right, let's see how you did. There's our answers right there. If you got them great. If you didn't, here's explanation. So first we have a logo for a recycling bin, something like this. And it's kind of like an equilateral triangle. And we want to have a side length of 6 centimeters. We want the area of the logo. So we're going to do kind of like we did on the other one. Well, first we need to find this height, which makes a right triangle. So we've got a 30, 60, 90, and we need the height. Only this time they gave us the long side. So what we have here, the long side, we need the, we have the hypotenuse, and we need to get the long leg. Well, the leg here, the height, is going to be the short leg times the square root of 2. Well, the short leg is half the long leg, so this is 6, so we have 3 for the short leg, times the square root of 3, so just 3 root 3. Plug that into our area formula, 1/2 base, remember base is all the way across, times the height, and we get area of 9 squared root of 3, which is about 15.59. Alright, question 6, we've got a dump truck. Want to know how high is this tip of this dump truck here when the angle is 60 degrees. So what I put that there. So again, this is 60 degrees, so we've got a 30, 60, 90 right triangle there. We are looking for the long leg again. Alright, so we've got to know what that short leg is. Short leg is half of the hypotenuse. So that means the short leg is going to be 7. And so 7 times the square root of 3 is about 12.12. Alright, and that is that. That is special right triangles and everything we need to know about them for right now anyways. Hopefully that helps. I'll see you all next time.